Hello everyone, welcome to another video of this Python series. So in this lecture, we'll be discussing about module and packaging from the file handling statements. So in the last lecture, we discussed about the OOPS, or that is object oriented programming, its functions and class object variables and its parameters and arguments and its real life problems, and with some complicated problems also, and some of the basic problems that we discussed and how it can be used in our daily it is we face OOPS in our day-to-day life, like you are using your smartphone, you are watching TV, you are using the remote of the TV, you are turning on the AC and whatever. So the command that you interpret in those is generally the input outputs things. So that we discuss, that is the sequence of the sum programming, and we did in the last lecture. And we also did polymorphism, encapsulation, inheritance, and um dry code also, that it should not be repeated. So we discussed about those programs in OOPS also. So let's start with our today's topic, that is modules and packaging. So let's get started with right away. So, so what Python modules and packaging. Python modules and packages are the building block of the scalable software. They allow you to organize code, reuse functionality, and prevent name conflicts. Introduction to modules and packages. What is a module? A module is simply a file ending in .py. It contains variable functions and classes that you can reuse in Python files. What is a package? A package is a collection of multiple modules organized in a folder hierarchy. Think of a module as a file and a package as a folder containing those files. For Python to treat a folder as a package, it traditionally contains an initialization file, that is init.py. Here is an example of it, that is my project is in main.py and my package, and that is in init module 1 and module 2. So that is your main script, that is main.py, and my package is your package folder. Init.py makes the folder as a package, and module is submodule, and same for the module 2 is also a submodule. Next is the import and from import statements. To use code from module, you must bring it into your current file. Python gives you two primary ways to do this. The import statement. This imports the entire module to access its content. You must use the dot notation module name dot function name. Syntax is import module name. Pros: prevent naming conflict. You always know exactly which module or function came from. Cons are code can become wordy if you reuse the module name frequently. Here is an example of it, that is import math. You must prefix the prefix the function with the math. Result is equals to math.sqrt 16. Square root of 16, that is 4. Next is the from import statement. This imports specific function, classes, or variables directly into your life. You do not need to use the module name prefix. Syntax: from module name import function name. Pros: cleaner, shorter code. Cons: can use naming conflict if two different modules have functions with same name. From math import sqrt pi. Print square root of 25 and print pi. The value of square root of 25 will be 5, and the value of pi will be 3.1415926535858973, and so on. Module aliasing. as keyword. If a module name is too long or you want to avoid a naming conflict, you can give it a nickname using the keyword as. Import date time as dt from from math. Import factorial as fact. Like in the questions of statement questions in maths, we usually give some speed variable as s and the variable acceleration as a. In some math question, we let them or assume the functions like let a be acceleration of the question that is given in the question, let s be the speed of the car that is in the question, according to the question, sometimes like that. So same as the module aliasing, that is we can use if a word or a name is getting into conflict in the code, so we can just use the aliasing method that will help us to prevent the naming error and naming conflict in the Python code, so that your test cases will run easily and without any conflict of name. So let's dive deep into the core of built-in modules. So Python comes with a rich standard library. Let's master 5 of the most essential built-in modules. So first is the math module. The math module provides access to the mathematical function defined by the C standard. It works with the real number, not complex number. First are the some key function, that is math.sale. It rounds up a number to the nearest integer. First, let's discuss all the function first. That is math.ceil of x function, math.floor, math.pow, math.sqrt, math.sin, math.cos, math.tan, math.radians, math.degrees. So let's start with the upper main first function, that is math.ceil. It rounds up a number up to the nearest integer. Math.floor rounds up a number down to the nearest integer, rounds down a number to the nearest integer. So it might decrease the value in the backward side for the nearest integer. Like if we want to round up 5.4, so it will round up to 5, and if we have 5.6, it will if we use math.ceil, it will round up to 6. And in the math.power, it raises x to the power of y, so it will turn y raised to power x, or x raises to the power of y. Yeah, it will do that, y raised to power x. And in math.sqrt, it returns the square root of x. Math.sin x, math.cos x, math.tan x. Trigonometric function expect radians, and math.radians divided by math.degrees converts angle between degrees and radians. So these are some coding problems that are import math, print math 4.2. Let's just see this. VS Code. We have already did the code length of almost 864 correct lines. Now it has turned to 871. Most of times I have just copied the code because it is just too much hectic to write and it will just waste your time. I just copy the code and make you understand what is in it. And I think that is the most efficient way to make you understand the lecture, make you understand the code, and I'll just help you make understand the main concept that is behind it. So here is the function that is used as math.ceil. So ceil is just like ceiling. Your ceiling, it is upward, and floor is your downward. Power is your exponential power. SQRT defines your square root, and radians defines your pi values. So when you use this math.ceil function, and if your value is in like any 4.1, 4.2, 4.3, anything, it will always go upward. Like here is 4.2, so it will go upward, so the next integer will be taken as your main number, so that is 5. But in the floor function, generally floor is on the downward side, so it will go downward, so that is 4.7, so it will give you the output of 4. And it, you can see right here. And in the math dot power function, it will give you 3 raised to power of 2. But that turns not out to be main function. It will x is raised to the power of 3, so it will give you 8. Print math.sqrt of 81. The square root of 81 will be 9. Print math.radians of 180. 180. The output will be pi, the value of pi. Not the exact value of pi. Maybe it is exact. It is exact, I guess. Yeah, it is exact. I think the formula is 180 by 180 multiplied by pi. So 180 will cancel 180 and the answer of pi will be 3.14 something. The random module. The random module implements pseudo random number generator for various distribution. It should not be used for security or cryptography purposes. The use of the secret module for that. Key functions are random.random returns a random float between 0.0 inclusive and 1.0 exclusive. Random.randint a comma b that returns a random integer between a and b, both are inclusive. Let's just see how much time it has been. It's expected it was like 12 minutes or something. Hmm. Next is random.randrange, that is start, stop, step. It returns a randomly selected element from a range. Random.choice sequence selects a random element from an empty list, tuple or string. Random.shuffle list shuffles the element of a list in the place. Random.sampleSequence.k, k returns a list of k unique elements chosen from a sequence. Next is import random. Generate a random integer between 1 and 10. Print random.randint 1, 10. Colors is equals to red, blue, green, and yellow. Print random.choice of colors. Number is equals to 1, 2, 3, 4, 5. Random.shuffle numbers. Print numbers. Print random.sample colors, 2. Hmm. So we are importing a file that is random and generate a random integer between 1 and 10, and colors is equals to red, comma blue, comma green, comma yellow. Print random dot choice of colors. Let's put all the time. So 30 divided by 4, that is equals to 4 7s are 28. Alright, much time I have left, but I guess it is enough. And at time of 50 minutes. Yeah. So the colors is equals to red, blue, green, and yellow. Print random dot choice of colors. Number is equals to 1, comma 2, comma 3, comma 4, comma 5. Random dot shuffle that are numbers. Print are numbers. Then the order varies from 3, 5, 1, 4, and 2, and get the unique items will be print random sample of color, that is colors of 2. So first it will be printed as 2 because it is the second one in the list. So the second color will be printed as blue. Then the random integer has changed. It will shuffle those numbers, then it will print the two colors that are green and yellow. It will shuffle them. Next is the date time module. The date time module supplies classes for manipulating dates and times. Core classes. Date time dot date represent a date, year, month, and day. Date time dot time represents a time, hour, minute, second, microsecond. Date time dot date time represent both date and time combined. Date time dot time delta represent the data difference between two dates or times duration. Key operation. Date time dot now gets the current local date and time, strft time format, converts the date time object into a readable string, strp time, that is string and format, parses a string into a datetime object. From datetime import datetime time delta now is equals to datetime dot now, print now, comma now, birthday, date time 1995, 5, 15, 10, and 30. Print birthday, comma birthday. Formatted date is equals to now dot strf time, and the syntax for the date and time is year, month, day, hour, and minute. So it will be formatted as like print formatted, and the formatted date that is from this variable right here. And this now it is doing the passing of strings of the dates. So date string is like here, it will have the value stored as 25 December 2026, and the pass date is date time dot strip, not actually strip, is strp time date string, that is day, birthday and year, date, birthday and year, print past object and past date. Let me check this. Right, let's see. 10 days ago, date arithmetic time delta. 10 days ago is equals to now minus time delta days is equals to 10. Future date is equals to now plus time delta weeks is equals to hours is equals to 5. I will just the OS module. The OS module provides a portable way of using operating system dependent functionality. It allows your Python code to talk directly to Windows, Mac OS or Linux. Key functions: os.get cwd, current working directory, os.get cwd. It returns the current working directory, oschdin. This is really like not usable in your INT syllabus, 108 syllabus. So you can skip this, but I will just explain. os.get cwd, it returns the current working directory, oschdin. It returns the changes in the current working directory to the specified path, os.list.dir path. It lists all the files and folder inside the directory. ok.mk, os.mkdir path, os.makedir's path. It creates a single folder or nested folders. os.remove path, that is os.rmdir path. It deletes a file or an empty folder. os.path.join path1, path2. It smartly joins folder path together based on the operating system. os.path.exist path. It checks if a file or folder exists. Import os. The current directory is equals to os.get cwd. Prints current folder, current dir. It will then list all the current folder contents. Print folder contents, os.list.dir. Then let's skip this code, which is not really that necessary. Then using mkdir, it is generally in the CC1 triple one. It was in that when we were studying, I guess, kernel or maybe Linux. It was in Linux. The directories were in Linux. So these are the commands mainly of Linux: cwd, dir, and cat, whatever they were. Those were the commands of the directory that works in the Linux, and it is not that necessary. The pip tool package installer for the Python. Actually, wait a second.